is to write that answer right there. You could write it like this, or like this, or like this. It doesn't matter.
Take for the all four of them.
No,
take that back.
I did the first one right.
I can make it. I don't even know. Who's next to you are?
You were like,
let's talk about this one. Is there more than one way to do this? I mean, most of you, I'm guessing, multiplied those together and then took the square root. It works, but I wanted to refresh your memory of sometimes you may not have a calculator or you have to simplify the square root. So I wanted you to realize that you can do this. This is, an acceptable rule, which is part of the step of simplifying square roots. So then you really didn't even need a calculator to do it. And we're going to look at that a little bit later again. Cool? Okay. Janie had her surgery today, so say, get better, Janie. Harshie. Say it loud. Feel better, Janie. There you go. Okay. So, let's just do some of this. Some of it will be very familiar. Some of it was a little bit slightly, maybe new, but I'm sure you've done this before. Simplify the ratio. So let's remember the wording in ratio. When you have a ratio, what does the word 2 tell you? Which one goes on top? The first number, right? The word in front of the word 2. So we have the same units here, so we can just do 24 to 3, but we have to reduce it always. So that equals 8 to 1. And what are the other ways to write a ratio? A colon and the word 2. Yeah? Most of the time in the book you're going to see it this way. But it could also be written as a fraction. Just the word, yeah. Okay? So these are also the same units. So it's 150 to 6. So you put the 150 on top. And it's 25 to 1. Most likely you'll see it like that in the book. Okay, now we have a slight problem. What is it? Different units. I don't really want to deal with the units, but I need to consider them. So I'm going to write a conversion fraction here. So if I want to eliminate the feet in my conversion fraction, I've got to put feet on top and inches on the bottom. Yeah? I'm going to eliminate the unit feet and the unit inches. Now, if I have 1 foot, how many inches are there? 12, right? So that becomes the conversion factor there. And then you can cancel your units, feet, feet, inches, inches, and you just deal with the numbers. Yep. So you just deal with the numbers now. 36 over 108. Does anybody know how many times 36 goes into 108?
4. 2.5. 3.
3. It's 3. Okay? So this would equal 1 to 3. 1 to 3. All right, that is that. You can. Either way. All right. Okay, so let's go a little further with this. The area of a rectangular garden is 108 square feet. My brain, I just have to do this. I can't help it. Okay, rectangular garden, area 108. Maybe you don't need that. Let's keep going. And the ratio of the length to the width is 4 to 3. Now, whenever I see something like this in a word problem like this, I automatically think 4 parts to 3 parts. It's not the actual number 4 and the actual number 3. It's 4 parts to 3 parts. Do we know what that part is? No, so we would represent it with a variable, like x. So this would be 4x to 3x. So, find the length and the width. Well, they're telling me here that the length to the width. So my length is 4x, it's kind of obvious, and my width is 3x. 4 parts to 3 parts. Oh! You know how to find the area of a rectangle. What do? Multiply length times width, right? So 4x times 3x equals what? 108. So, now we just have an algebra problem. You multiply the numbers together, 4 times 3, which is 12. And what is x times x? X squared equals 108. So you finish it by doing what? Divide by 12. You get x squared equals 9. Take the square root. Now you're going to get a positive 3 and a negative 3. Does the negative 3 help us at all? So we just use the positive 3. So x is equal to 3, but of course we are not done with that problem yet because we have to find the length and the width. So 3 times 4 is what? 12. So the length is 12 feet and the width is 9 feet. Nifty, huh? Yes.
But couldn't it be negative because it was still equal 108?
But when you plug it back in, you would have a negative 9. You can't have a rectangle that's negative 9 side lengths, right? Yes. All right. So in the same kind of idea here, the measures of the angles of triangle RST are in the extended ratio. All this means is that the ratio is more than 2 numbers. So obviously you can't write it as a fraction, more than 2 numbers. So it's in the extended ratio 2 to 3 to 4. Find the measures of the angles. I don't know, I'm just going to draw a little picture here of some triangle. I'm just going to label it RST. You may not have to do that, but now, when you see this in terms of geometry like this, it's 2 parts to 3 parts to 4 parts, right? Which basically means 2x to 3x to 4x. So one of my angles is 2x, one is 3x, one is 4x. I know that's not to scale. It doesn't matter. It's just to help me figure the problem out. 2 parts to 3 parts to 4 parts, correct? What do I know about the angles of a triangle? They add up to 180. So I can write that as a sum. And so then I have 9x. And then divide by 9, and x equals 20. But I'm not done yet. Okay? One of my angles is 2 times 20, which is what? So 40 degrees. And then 3 times 20, 60 degrees. And then 4 times 20, 80 degrees. So the angles of my triangle are that. And then, of course, you should probably double check that they add up to what? 180 before you walk away from the problem. Cool? Alrighty. Solve the proportion. When you have 2 fractions that are equal to each other, how can you solve this proportion? Cross multiply. So you do this. You do 8 times 27, and then you put the equal sign. And then 24x. So that's 216 equals 24x. Then divide both sides by 24, and you get x equals 9. That's solving. No problem. The only thing now, in this problem here, you have to just do one thing before you cross multiply. Don't forget to do what? Yeah, or just put that in parentheses, basically, so you don't forget to distribute. So you would write it like this. 2 times 4x. You don't have to put this in parentheses because you're just going to multiply the numbers together. So then you have to distribute. And subtract 5x, and you get this, and x equals 5. Okay, you do this one. Do this one. 6. If you didn't get it, just take a look real quick, and then we'll go on to the back. That was pretty much...
Oh, wait, I got that
Okay. Okay. So that's pretty much 6.1, not a problem, right? Let's go and do 6.2. All right. There's triangle. Geometric mean. The geometric mean of two positive numbers a and b is the positive number x, so this is what you're looking for, x, that satisfies this proportion. Let's read what this says. You don't have to write this down, but I'm just going to draw you a little picture of what this definition means. It says the geometric mean of two numbers a and b is simply the length of the square whose area is equal to that of the rectangle with dimensions a and b. So let's say I have a square, x and x, and the middle of that is x squared, right? It says the length of the square whose area is equal to that of a rectangle with dimensions a and b, so that's a times b. So this is what this definition is saying. You don't really need to memorize that, but that's where they come up with this. X squared equals a times b. See it? I'm just kind of explaining where the definition comes from, and what you're looking for when you're doing the mean, when they ask you for the geometric mean, you're looking for x. So you could use this form, but that's still kind of messy. It's easier if you take the square root of both sides and you get x equals the square root of a times b. This will give you the geometric mean right there. X equals the square root of a times b. So, and that'll come into play a little bit more in chapter 7. But for now, we're going to just kind of do the basic calculations with it. It says find the geometric mean. So we're looking for that x using this. So this is my a and this is my b. These are my two numbers here. And I'm looking for x. Okay, so all I do is plug it into here. X equals the square root of 12 times 27. And x equals 18. That's it. When you multiply these together and take the square root. All right. So then this is A and this is B. So, but wait a minute, don't get calculator happy yet. If we do this one here and we do all the math, we end up with a decimal, which isn't exactly accurate because we had to round. That's what the squigglies mean. I had to round. It would be better to get the exact geometric mean, which means that we would just simplify the square roots. So that's why we had that little warm-up. So I'm going to write this one over here. If we have to simplify the square root, we would split these two up. Probably. Maybe you could multiply them together and then do it. Take a look, you guys. Okay, what is a perfect square of factor of 18 that's a perfect square? Yes, 9. So I'm going to rewrite the square root of 18 as the square root of 9 times the square root of 2. And I'll show you why in a second. Then I'm going to take 54. What's the biggest thing that goes into 54 that's a perfect square? 9 as well. So I'm going to rewrite that as 9 times the square root of 6. Then I'm going to take the square root of whatever numbers I can without a decimal, which would be both of these, right? So the square root of 9 is 3, and the square root of 9 is 3. We'll be able to go further with this. And then I still have the square root of 2 times the square root of 6. I'm just going to write that like that. And then it equals this. You want to be done with it, but you're not. Because if you have this, you can put, just like you can split them up, you can put them back together underneath 1. And we can go further. Because 12 has a factor that is a perfect square, which is what? 4. 4. So the 9 stays there. I split it up to this. And then we take the square root of 4, which is 2. 2 times 9 is 18. And that is our exact answer. Without a decimal.
How does that help you more than just? Because it's more information.
When you get into special right triangles, you've got to know how to do this.
When will that be?
I don't know what chapter it is in this book. We'll find out. Okay? This will be a 30, 60, 90 triangle, one of the sides of a 30, 60, 90. All right. So you guys do this one. Do this one and simplify. Go for it. Just like I did that other one. So this is just working with the mean. This, we're going to set up a proportion to help us solve this. So it says in the diagram, find ST. All right, so you notice that here is ST, right? It's this length right here, which is what? X. We got to find that. And we have to find VT, which is this piece right here. So we're going to set up a proportion because we have similar triangles here, which we haven't really defined yet. But I can say these sides are corresponding. They're in the same spot. So I can say 8, you see this? 8 is to X. So I'm going to write 8 is to X. As is my equal sign. And then I'm going to look and see if there's another part of this triangle where I can actually write another ratio. And I can say as this piece here is to this whole piece. 12 is to 12 plus 28 because I want the whole side length. See how I set that up? So you just kind of look around to see how you could set up a proportion. And then you can solve for X here. So this is 40. Cross multiply. You get 8 times 40 is 320 equals 12 times X. And X equals 26.666666. Hopefully in your mathematic career, you already know what fraction that is. 0.66666 is what? 2/3. So I would write 26 and 2/3 to be more exact. Because if you round it to 0.67, you're taking away the exactness. Right? All right, now we're not done though. We have to find ST and VT. So ST is what? My X, isn't it? So it is 26 and 2/3. And VT is this little piece here, so I have to take away what? 8 from 26 and 2/3, so that would be what? Just do it in your head. You can do it. 18 and 2/3. Okay? All right, let's move on then. You guys have read a map before, yeah? Oh, maybe not. You guys have, you have GPS? There's a sad thing that's gone away, map reading, man. All right. The scale of a map is 1 inch to 1,414 feet. Do you know what that means? Every inch on the map is 1,440 feet in real life. Okay, so I'm just going to write, that's a ratio. I'm going to write it, 1 inch to 1,440 feet. This is the actual number there. Find the actual length of a street if the distance on the map is 3 inches. So I can set that equal to a new ratio where on the map it's 3 inches, but I don't know how many feet it is in real life. Since we're finding feet here, we don't really want to eliminate anything, so we don't do any conversions here. We're just cross-multiplying the numbers. That's all we have to do to find out what number is going to be down here. So we do 1 times x equals those 3 inches on the map times 1,440 feet, because each inch is 1,440 feet. So 3 times 1,440. And x equals 4,320 feet. Cool? Almost done. You buy a 3D scale model of the Sears Tower. It's not even called the Sears Tower anymore, but whatever.
Yeah, I knew that.
What's it called now?
I can't remember. Hancock Building, or has that changed since then? The actual height of the building, including the TV antenna on top, is 1,703 feet. Your model is 29.4 inches tall, including a 4.4 inch antenna on top of the model. So I'm just going to say to myself, all right, how do I want to set up my proportion? You could do it different ways. I'm going to set it up to have the antenna over the actual height, or total, let's say total height. So I'll start with a model, because I have both of those pieces of information. My antenna is 4.4 to the total height of 29.4, and I can set that equal to, I don't know the antenna of the actual building, but I know it's 1703. Antenna over total. This is an inch one and this is a feet one, so it works out okay. When you cross multiply, you get some big number, 29.4 equals 7493.2. Thank you. Then you divide by 29.4 and you get approximately 255 feet. We'll go with approximate for this one. So the antenna is about 255 feet.
Well, what if that was a bug?
Okay, let's finish this. About how many times as tall as your model is the actual building, including the antenna? So the actual building is 1,703 feet. I got to divide it by how tall my model is to find out how many times as big it is. Well, my model is 29.4 inches. Now that's a problem. I can't divide those two. I got to convert the inches to feet to find out how many times as big. So how do I do that? I do take 29.4 and do what? Divide it by 12 inches. That'll give me the feet. So it's 1703 divided by 2.45 feet. My model is actually 2.45 feet tall. And it's approximately 695 times as big. Yep. Not so bad, huh?